Hello, hello, welcome back for Chapter 6, Lesson 3. We're talking about conditions for parallelograms today. But before we get started with today's lesson, we have this warm-up, 1, 2, 3, 4, 5. And if you can go ahead and get started on those, here's my friend the Pause Dragon. Remind you to pause your device, work out those problems. When you get done, we'll talk about them together. All right, see you in a bit. Okay, let's see how you did. So the first one, the line segment QR is congruent to line segment QR. That is the reflexive property of congruence. So if you got that one right, great job. Looking at the figure here, it says L is parallel to M. And if you look at that, we're trying to say, see why. Why is this? Why would L and M be parallel? And we have a transversal here. It looks like those alternate interior angles are congruent. So that means by the converse of the alternate interior angles, that's why L and M would be congruent. So blast from the past, converse of alternate interior angles theorem. That's why those two lines are parallel. Okay, evaluate each expression for x equals 12 and y equals 8.5. Perfect. Okay, so let's look here. We're going to substitute that in. This should be pretty straightforward. You should have 31 if you got that. Great job. Let's look over here. Same thing. 16 times 12 minus 9. 16 times 12, I don't know what that is. 3, 6, 1, 2, 9, 192. Minus 9, what would that be? 83? 183? Would it be 83? Or would it be 84? No, 83, so 2. It would be 83. Yeah, 183. Okay. And then over here, we have 8 times 8.5 plus 5. Okay, I don't know what that is. 40, 64, 68, 1 decimal place. So 68 plus 5, which should be 73. So if you got all those right, great job. Okay, now we are going to be talking about the conditions for parallelograms. These should all be a flashcard. Okay, you're going to have to memorize all these. So make sure you're going over these so that you can commit them to memory. All right. 631, it says if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. Okay, so let's talk about this for a second. So last section, 6.2, it was all about, all the theorems were like, if this is a parallel, if a quadrilateral is a parallelogram, then blah, 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 right? So it was always like if a quadrilateral is a parallelogram, that was it. Had to be a parallelogram, and then it opened this treasure box of all these theorems, okay? Now this section is all about like going backwards, okay? So we don't know that it's a parallelogram. And so these are 1, 2, 3, 4, 5 things that if these 5 things occur, then you know it's a parallelogram. Okay, so in 6.2, we started with it's a parallelogram, and then we were able to say things. This one, we are not starting with a parallelogram. We're noticing things, and then because of that, you can then state it's a parallelogram. All right? So, first one, it says if one pair of opposite sides of a quadrilateral are parallel and congruent. So if you look here, it just says one pair of opposite sides of a quadrilateral, so we don't have a parallelogram, right? It's just a 4-sided figure. A quadrilateral is parallel and congruent. So here we have it. There's one pair of sides. They're parallel and they're congruent. And if you have one side that's parallel and congruent, then you can say that the quadrilateral is a parallelogram. So the theorem is quadrilateral with parallel of opposite sides, parallel and congruent, then it's a parallelogram. Okay, so that's the first one. The second one is actually really similar to one in the previous lesson. It says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you have both sides, right, these are congruent and these are congruent, then you have a parallelogram. Quadrilateral with opposite sides congruent, then it's a parallelogram. So it's both pairs of opposite sides of a quadrilateral are congruent, then you have a parallelogram, okay? This one also is very, very similar to the one in last section. It says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we have one opposite angles that are congruent, and then we have another set of opposite angles. So if both pairs of opposite angles of a quadrilateral are congruent, then we have a parallelogram. So quadrilateral with opposite angles congruent, then it's a parallelogram. Okay, so far this one is kind of new, right? With only one pair of congruent and they're parallel. But these are just very similar to last section. They're just the converse of it, right? Just like how we did with the alternate interior angles, right? We had the alternate interior angles, and then the next lesson we talked about the converse of the alternate interior angles, and then the converse of the same side interior angles, and then the converse of the corresponding angles postulate, and the converse of the alternate exterior angles theorem. So that's kind of like the same thing here, okay? We talked about if there's a parallelogram, then blah, 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 and now we're kind of going the converse, even though they're not called converse, but it's kind of that idea. Okay, so far we have, if you have one set of sides that are congruent and parallel, boom, it's a parallelogram. If you have both pairs of opposite sides that are congruent, then it's a parallelogram. If you have both opposite angles that are congruent, both pairs of opposite angles, then we have a parallelogram. Okay, let's look at this one. This one says, if an angle of a quadrilateral is supplementary to both its consecutive angles, then the quadrilateral is a parallelogram. So this one is kind of similar to the one last section, but it's a little bit different. I think it was just like if you have a parallelogram, then the consecutive angles are supplementary, but for this one, you need both pairs of consecutive angles, right? So here's our angle, and it has to be supplementary to this one and this one. So this angle has to be supplementary here and here for it to be a parallelogram. So if an angle of a quadrilateral, so we have an angle is supplementary to both its consecutive angles, then the quadrilateral is a parallelogram. So quadrilateral with angles supplementary to consecutive angles, then it's a parallelogram. All right, so that one's kind of like, but it's a little different because you have to be consecutive to both. You have to be supplementary to both consecutive angles. That's what I'm trying to say. Okay, perfect. All right, let's look at this one. It says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So again, this one is very similar to the one last section. Okay, so we have a bisecting of the diagonals. This side is congruent to this, and this side's congruent to that side. So if that happens, then you have a parallelogram. So if the diagonals bisect each other, and it has to be both, right? It can't just bisect one. It has to bisect both. Then the quadrilateral is a parallelogram. So quadrilateral with diagonals bisecting each other, then it's a parallelogram. So I would say that this one, the opposite sides, the opposite angles, and the bisecting are exactly the same. It's just kind of like, these are kind of like the converse of last section. This one is similar. The only thing is you need both consecutive angles. And then this one is kind of like new, right? It's got to be parallel and it's got to be congruent. Okay, that is it. So those are the conditions for parallelograms. We are going to be applying these for this entire lesson. Okay, so let's go ahead and get started. What we're going to be doing first is we're just going to be appreciating what's going on. Okay, so the first couple we're going to be appreciating, and then we're going to do one together. Okay, so for 1A, we're verifying figures are parallelograms. We have this figure here. It says show that JKLM is a parallelogram when A is equal to 3 and B is equal to 9. Okay, so here we have some algebraic expressions. We're obviously going to have to substitute those values in for these algebraic expressions. I mean, just looking at it, if we have to prove it's a parallelogram, I mean, which of those 5 theorems that we just talked about does this look like? to me, it looks like we have opposite sides, opposite sides. Most likely, we're going to be using this one right here, right? If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So sometimes just kind of looking at the picture, you kind of get an idea of where the problem's going. So do you see that? Because you kind of have opposite sides. I mean, we don't have anything about lines being parallel or nothing about the angles and nothing about the diagonals. So that kind of just, you know, there's nothing parallel, there's nothing about the angles, nothing about the angles, and nothing about the diagonals. So sometimes you can just look at the picture and kind of know probably the direction that the problem's heading. So we have to prove that. So first we just have to substitute all these in, okay? So the first thing I'm going to do is I'm going to substitute it in for JK, this one, this side here, and this side here, LM. And it's really, so we have JL and LM, right? And so that's just given. I'm writing down the information, and then we're just going to substitute that in, right? So we're putting A is equal to 3 here, and we're just substituting it in for A. So it really becomes pretty easy here, and we're doing the same thing here. So 15 times 3 is 45 minus 11, and we get JK is equal to 34 over here. So, and it's just substitute, simplify, simplify, right? And then we substitute 3 over here for LM. 10 times 3 is 30, plus 4, 34. So boom, right there. They are equal to the same thing. So then that's great. So we know that these are equal, right? So now we're going to look for these ones here, okay? So now we're going to look at JM and figure out what that is, and KL. So first we're writing the given information. There's KL, there's JM, right? It's given, and then we, substitute B is equal to 9, right? So we're just substituting that in for B, and really that's just substitution. And then if you look here, 5 times 9 is 45, plus 6, 51, okay? So that's what KL is 51. And then we do the same thing. 9 goes in for B here, 8 times 9 is 72, minus 21, which is 51. So they end up being the same thing, all right? Just given, substitute, and then from there we're just simplifying on both sides, right? So here we're just stating JK is equal to LM, okay? And this would probably be more like substitution. And then we have KL is equal to JM. And I'm going to say that this reason is not given. Let's just get rid of that because we'll say it's substitution. Okay, and then basically, boom, we can state, because we have those opposite sides that are congruent, we can state that JKLM is a parallelogram because of theorem 632, a quadrilateral with opposite sides congruent, then it's a parallelogram. So this is how you would do your homework, okay? If it asks you to show that JKLM is a parallelogram and it gives you something like this and you're supposed to substitute in the values, okay? All right, let's go ahead and appreciate this one as well. So we're going to verify. So we're verifying that these figures are congruent. So just looking at this, okay, so we have an angle here. This represents an angle. This represents an angle. We have to show that this is a parallelogram. It says x equals 10 and y equals 6.5. Now, which of those 5 theorems do you think we're going to be using just by looking at the picture? Okay, so this is definitely going to be one that's dealing with angles, right? What do you think? What do you think? What do you think? So let's look at them. Okay, so we have the opposite sides, parallel. Okay, that picture has nothing to do with that. This is all about sides. The picture is all about angles. Okay, there's this one that has the opposite angles, but here we have one set of opposite angles, but we don't have the other, so it's probably not that one. But here we have an angle, and then we have its consecutive angle here and consecutive angle here, which is what we have, an angle, consecutive, and another consecutive. So most likely we're going to probably be using this theorem. It says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So I always think it's nice just to kind of have a heads up before I start the problem, like where is this problem going, right? And you can tell a lot just by looking at the picture. So now I have that theorem in my mind, and I kind of know the direction that I need to go with this problem. So first, we just need to write all this stuff down and substitute in those values, okay? So if you see here, I really did that for all three, okay? So we have the measure of angle Q right here. We have measure of angle S right here, which is that angle. And then we have the measure of angle R right here. And that's all given information, right? So I'm just doing all three of them at the same time because literally the justifications are going to be exactly the same. So here, if you see, this next one is just going to be substitution. So here it's 6y, so I'm putting 6.5 in for y. This one is y2, so you're getting a 6.5, and then this one's an x, so it's getting 10, okay? So we're just substituting those values all in. And then from there, you know, 6 times 6.5, that's 39, plus 7 is 46, okay? And then what do we have here? So we substitute 6.5 in here. 8 times 6.5 is 52. 52 minus 6 is 46. And then over here, we got 15 times 10, which is 150, minus 16 is 134 for measure of angle R. And the justifications, really, we substituted and then we just simplified from there. All right? So after that, if you go 46 plus, because right here, this one's 46 and this one's 46, right? And then this one's 134. So if you go 46 plus 134, that equals 180, which means that angle R, this one, is supplementary to both Q and S. Okay, so it's supplementary to Q and S because 46 plus 134 is equal to 180. Okay, and so that means that PQRS is a parallelogram by theorem 634, which is a quadrilateral with an angle supplementary to both of its consecutive angles, then it's a parallelogram. All right, so that's how you justify or verify, right? It's asking us to verify, and that's how you do that, okay? So you might want to use this as a guide as you are solving. Use these notes as you're looking at your homework. Use it as a guide so you know how to set up your problems. Okay, now let's do this one together. So what do we have here? Interesting. Okay, so it looks like we have a side here, and then we have an angle here. That is really interesting. So we have one side and we have an angle. So let's look here at what we have. We have a side and parallel. We have opposite sides, right? We know it's not going to be that one because we don't have both sides. We just have one set of sides. And then here we have the opposite angles, right? And we don't have enough angles to use that one. Here we have the one angle, and it's got to be consecutive to both, right? We have one angle, but we don't have both, so it's probably not that one. And then we have the diagonals, and there's nothing about diagonals. So I know that it's not this one. I know it's not this one. I know it's not this one. I know it's not this one, which only leaves this one. So let's go ahead and think about, let's kind of get started with the problem. No, we're going to be using this one, and kind of think, how would they incorporate that? I mean, the one set of sides is obvious, right? If you just show that those are congruent, but why would they have these two angles right here? Okay, so let's just get started. We're going to think about that, and hopefully as we solve this problem, it will become more obvious. Okay, so we have to show that PQRS is a parallelogram for A equals 2.5 and B equals 9. So let's just start with the side information, okay? So we're going to go here. So let's have PQ equals 7A, And I'm going to do this one as well. So RS equals 2A plus 12. And that's just given, right? And then we know that A is equal to 2.4. So we're just going to substitute that in. 7 times 2.4. And I'm just going to do the same thing here. And that's substitution. Okay? And then we just need to figure out what that is. 7 times 2.4. I'm not quite sure. I'm going to go off to the side. Figure that out. 7 times 4 is 28, right? The 8 carry the 2. 7 times 2 is 14, plus 2 would be 16. And then 1 decimal, so it's going to be 16.8. So PQ is equal to 16.8. Okay? Then we have to do this one. 2 times 2.4 is going to be 4.8. Plus 12 is going to give us that 16.8. So it was a simplify. Simplify. Perfect. Okay, and so what do we see? We see that these are both equal, so I'm just going to write that. PQ is equal to RS, and that's just substitution. Okay, so now we know that this is equal to this, so those are congruent. Let's go ahead and try to figure out the angles now. So I'm going to say the measure of angle Q is equal to 10B minus 16, and the measure of angle R is equal to 9B plus 25, and that's given. And then we're going to substitute what? B is equal to 9. So I'm just substituting it in both places. That's just substitution. All right, and then I'm going to work this one out. So 10 times 9 is 90, right? Minus 16. 90 minus 16, that would be 74 degrees. And then we got to do this one. 9 times 9 is 81. And that's going to be 106. Okay, this was what? Simplify degrees. Okay, so we have 74 and 106, right? We know that we're most likely going to be using this one, right? And this one says a quadrilateral with pair of opposite sides that are parallel and congruent. Well, we know what they're parallel, then it's a parallelogram, right? We know that they're congruent, but we need them to be parallel. Does this help us? 74 and 106. Well, what is 74? Like if we added those together, 106 plus 74, 6 plus 4 is 10, 7 plus 1 is 8, and 1, oh, they're 180. That means they're supplementary. Ooh, these are supplementary. What does that mean? So let's think about this. Since 74 plus 106 equals 180, that means that angle Q and angle R are supplementary, right? So that means that what? The measure of angle Q plus, wait, we just said that. Okay, so it means that they're supplementary. So then because they're supplementary, what can we say? We can say that these two lines, they're parallel, right? We can say that PQ is parallel to RS. Why? Because of the converse of the same side. Don't worry about this number here. Just don't worry about that. Same side interior angles. Interior angles. Do you guys remember that? The converse of the same side interior angles. Okay, so like if these lines are parallel, right, and that's my transversal, these would be same side interior. Are you guys seeing what I'm throwing down here? So let's say this, we need this and this to be parallel, right? So if that's a parallel line, and then this is our transversal, right? These are same side interior angles. And if they're supplementary, then we know that these two lines are parallel. And that's it, by the converse of the same side interior angles. So because they're congruent here, right? And now they're parallel, now we can say that PQRS is a parallelogram. Because a quadrilateral with pair of opposite sides parallel and congruent, then it's a parallelogram. So this is what? Theorem 631. Theorem 631, but I think I'm just going to go ahead and say it. So a quadrilateral with pair of opposite sides parallel and congruent, then it's a parallelogram. Boom! Okay, that is it for Check It Out Example 1, and I'll see you in a little bit for Example 2.